Lesson: Troubleshooting Common Issues in AI Operations. Troubleshooting common issues in AI operations is a critical skill for any professional seeking to excel in the field of artificial intelligence. As AI systems become increasingly complex and integral to business processes, the ability to effectively identify, diagnose, and resolve operational issues is paramount. This lesson provides a detailed exploration of common challenges encountered in AI operations, offering actionable insights, practical tools, and frameworks tailored to enhance proficiency in managing and maintaining AI systems. AI systems, by their nature, are intricate and can present a myriad of operational challenges. A common issue is data quality, which can significantly impact the performance of AI models. Poor data quality can arise from several sources, including data entry errors, outdated information, and inconsistent data formats. To tackle this issue, professionals must implement robust data validation and cleansing processes. Tools such as the open-source framework Pandas in Python provide powerful data manipulation capabilities, enabling users to clean and pre-process data efficiently. Implementing automated data quality checks as part of the data pipeline ensures that issues are identified and rectified early, minimizing their impact on the AI system's performance. Another prevalent challenge in AI operations is model drift, which occurs when the statistical properties of input data change over time, leading to a decline in model accuracy. To address model drift, continuous monitoring and retraining of models are essential. Frameworks like MLflow offer a comprehensive platform for model tracking, enabling professionals to monitor model performance metrics and implement retraining schedules automatically. By setting up alerts for significant deviations in model performance, organizations can proactively manage model drift, ensuring the AI system remains accurate and reliable. Resource management is another critical area in AI operations, often manifesting as issues with computational resources, such as CPU and GPU utilization. Inefficient resource allocation can lead to bottlenecks and increased operational costs. Tools like Kubernetes offer powerful orchestration capabilities, allowing for the efficient allocation and scaling of resources based on workload demands. By leveraging Kubernetes auto-scaling features, AI operations can dynamically adjust resources to meet real-time processing needs, optimizing performance and cost efficiency. In addition to technical challenges, AI systems often face ethical and legal issues, such as bias and fairness. Bias in AI models can lead to unfair outcomes and damage an organization's reputation. To mitigate bias, it is crucial to implement a comprehensive bias detection and mitigation framework. The Fairness Indicators tool, developed by Google, provides a suite of metrics for assessing fairness in machine learning models, allowing practitioners to identify and address potential biases before deployment. By regularly auditing models for bias and incorporating fairness metrics into the development process, organizations can ensure that their AI systems operate ethically and equitably. Security is another vital consideration in AI operations. AI systems are vulnerable to various security threats, including adversarial attacks and data breaches. Implementing robust security protocols is essential to protect AI systems from such threats. Tools like IBM's Adversarial Robustness Toolbox provide a comprehensive suite of functionalities for testing and enhancing the security of machine learning models against adversarial attacks. By integrating security testing into the AI development lifecycle, organizations can safeguard their AI systems and maintain trust with stakeholders. Case studies provide valuable insights into the practical application of these tools and strategies. For instance, a financial services company faced challenges with model drift, which led to inaccurate risk assessments. By implementing MLflow for continuous model monitoring and retraining, the company was able to maintain high model accuracy and improve decision-making processes. Similarly, a healthcare organization leveraged Kubernetes to optimize resource allocation for its AI-powered diagnostic tools, resulting in reduced costs and improved processing times. Statistics further illustrate the importance of effective troubleshooting in AI operations. According to a report by Gartner, poor data quality costs organizations an average of $15 million annually. This statistic underscores the necessity of implementing robust data management practices to ensure the success of AI initiatives. Additionally, a study by McKinsey found that organizations using AI operations tools effectively can achieve up to 20% higher productivity. Such data highlights the tangible benefits of adopting comprehensive troubleshooting frameworks and tools. Ultimately, the ability to troubleshoot common issues in AI operations is a critical competency for professionals in the field. By leveraging practical tools and frameworks such as Pandas, MLflow, Kubernetes, fairness indicators, and the adversarial robustness toolbox, professionals can address real-world challenges effectively. Implementing these tools and strategies not only enhances the performance and reliability of AI systems, but also ensures they operate ethically and securely. As AI continues to evolve, staying abreast of the latest developments in troubleshooting and maintenance will be essential for success in AI operations.